Good evening, everyone. Thanks for staying that late. So today I'll talk about real-time big data framework. I'll take you through the component that constitutes the real-time big data framework. During that presentation also I'll tell you about few customer stories, use cases that actually have been behind the concept and also the design of that framework. And I'll finish by also a call to actions also. So for those who are interested to embark into a big data story, how can Red Hat help you? So from the services side. And a little bit about myself. I'm basically an engineer, so I don't always wear a suit. But it's a pleasure for me also to talk about the products and to meet with the partners and the customers here. So I think today the challenge we have is not lack of information. There is a lot of data that we talked today about in the previous sessions and also at the keynote about IoT, how much IoT generates data. Not only on social media, but IoT, and IoT is everywhere. I just bought a Fitbit, and it's basically streaming my heart rate to my phone. So it's everywhere. So we have social media, IoT, and also traditional data captures we've been doing, especially around e-commerce. A lot of you have been involved in e-commerce application development and also designing, architecting those solutions. And when those go live, of course, you need to access, to understand what's the usage patterns, what are people doing with your e-commerce site. So big data have started more than 10 years ago by weblogs, by capturing informations. And this is still happening today. A lot of people are still doing weblog analysis. It's very important for them to understand the trends. But that's not enough, and that's what we'll talk about today. I think, how do you make sense now of your old data and the new data you can access, whether through social media and also through new technology, especially with open source platforms we've mentioned today that allow you to have direct insight in that information. So I gave another example. I was shopping for some toys for my son on hobbyking.com. And that site knew exactly which information I was looking for, which components, which parts, which toys I was looking at. And I had a little pop-up and I was telling me, oh, you should look at that. Have you looked at that promotions? So it's a very important for newcomers to make, to push this kind of notifications either through the mobile platform, which you just saw as an engagement platform with your end users, or through the web itself, as we all know. So it's very important for companies to understand and make sense of that information and leverage it to create business value. So typically what happens in Internet Minute, you see some numbers. This is staggering. It's unprecedented amount of data. And we saw this morning with Brian Shea's talk that the market for especially connected device is going to reach tens of trillions of dollars by 2025. And these trends, they're not going down. So that was 2014, and by 2015, you see that the number of connected devices is 2 times the global populations. I was never into Fitbit, but I got one because these add value to. There is a lot of benefits from those connected devices that we're going to actually talk about with some of the examples I'm going to share with you later. So I mentioned earlier that typically customers have been collecting data in a structured way. So that's the traditional SQL data store. Very often you see even weblogs that come from Apache logs on e-commerce sites usually are captured and transformed into and mapped into a database table, so they can be interrogated through batch processing and extract some intelligence, some information to detect patterns and behaviors of people browsing your applications. That also capture records for sales, for invoices, for product inventory, for a number of things. And usually people use that information to make decisions that are based on those usage patterns. We see a number of data also coming from semi-structured data, also from, I mentioned weblogs, but spatial information, typically mapping data. So this is even going even more and more along with machine generating data. We talked about connected devices, sensors, RFIDs, and we talked about an example earlier, which was an hospital that actually implemented a very interesting platform to connect patients to doctors. But not only that, we also see some new textiles, some new devices or new sensors that allow, for example, the staff in a hospital to interact or to for example, look at patients when they need it, or sometimes don't change maybe a dressing because there is no need. So I think there is a lot of evolution, lots of information that's going to come from those environments. Okay. So if we can define that describe that with simple definition, big data is a collection of data from both a traditional and digital source inside and outside your company that represent a source for ongoing discovery and analysis. So we talk about analysis, but I think there's an important concept about when do you analyze that data and how do you get value of that data, and how do you close the gap between the time you capture it and the time you get value out of and make business decisions, whether it's to upsell, cross-sell, or to make decision to stop a disaster, or to maybe if you're a utility company, maybe to shift the load or the power towards certain regions or environments. So you can, the goal of that presentation is to talk about how you turn big data into actual actionable business insight. So that revolves around two facets. The first one is big data at rest. I think you probably heard about that term. Big data at rest is what we've seen before, the collection of different data from various sources, from structured, unstructured data sources, whether it's SQL, NoSQL, and analyze. So we go and analyze that data. However, we act separately. That's two different things. There's the collection process and the analytics after that. And that's an important difference with the next facet of big data, which is big data in motion, is the time. So it's purely a batch processing driven. So usually you have to wait the next day. So many of us, including myself, when I was working on especially in the e-commerce industry and also in finance and commodity trading, we had to wait for bookings or end-of-day processing to finish to actually analyze that data, and probably a day or two after make decisions based on the results. The second facet is big data in motion. So it's a similar collection process. However, the analytics here occur in real time. That's a fundamental difference with data at rest. And this is very common in the telco sector. Like when I landed yesterday from Singapore, I got a message saying, do you want that promotion for data plan? So it's very important to for companies to react on real-time events, you know, on different, because if they send me that promotion tomorrow, I'll be gone. So I think that it's very important for businesses to react to those events. So the opportunity here lies in the time window. That's a very big difference with big data at rest. But how are we going to address that? There's other examples where we work very closely with a company that in the transport and logistic sector, which is FedEx, where one of the biggest issues for them is when they do organ transplants, the transportation of organs. This is very critical, very important to understand the temperature inside the truck. And if that temperature, for whatever reason, there is a failure in one of the systems, you need to make decisions in real time. You need to decide now, not in 10 seconds, but sometimes 1 second makes a big difference when you need to take an exit, go to the next, reroute to the next point where you can actually change to another truck and fix it and deliver the organ to the right hospital in time. So this is the biggest difference. So with FedEx, we work very much on complex event processing. So this is very important when you get those information from those sensors to be able to react immediately. Okay. So the value proposition of real-time big data framework lies in the combination of those two facets. Big data at rest, where you have to capture data, store, and batch process and do a batch analysis, and the real time to act on identified customer segments that you've also identified also through the model, through the batch analysis. So combining batch and real-time analysis provide maximum actionable business insight. So that's where the world is moving now. You cannot ignore that, and that's where big data is moving also. So how does it look like? So we can summarize this as agile business insight and action through both real-time analysis and integration of data in motion and data at rest. So we need to have the ability to analyze very large quantities of stream data in real time. So of course, an architecture that can scale efficiently, and a flexible analytic approach where you can actually bring decisions, business rules during that analysis so you can make decisions. So we're using a JBoss BRMS for that. And also we need to be able to consume flows from structured, unstructured, from Internet of Things. So open source plays a big role. We talk about today about a number of standards around, especially around IoT. So like MQTT, for example. We have other open source or standard-based protocols that we support, like STAMP, MQP, sorry. So open source is a very important environment, not only to validate standards, but also that's where they develop, they grow. It's certainly not in the proprietary world where you see the ecosystem collaborating together to develop those standards and validate them. And I think open source is the best channel for that. Of course, proven success, this framework we're talking about today is based on actual use cases. So we are actually, with our teams on the ground, took the best practices and identified the components between the consumption of your data, the analytics of your data, and the ability to act on that data and make sense of it. And how do you present that data also to business stakeholders to drive value out of it? So we have all the components and assembled that in a comprehensive architecture. So some of the use case, I mentioned upsell, cross-sell. There's also an example about social media analysis, the trends. There's actually an example in Japan with security response team that analyze tweet feeds and geolocations to actually target response units. There's also some demos we've done at the Red Hat Summit. I don't know if you had the chance to join the Red Hat Summit this year, where we use Bluetooth and beacon, because sometimes you don't have GPS signals. You have to find other ways to track your devices, or track movements of crowds, or movements of packages, or movements of a number of things. So we have used different technology to demonstrate that. There is also, I mentioned FedEx. We also have a number of use cases in banking, especially around fraud detections. So, and that actually, I receive quite often calls. I travel a lot around the world. And this year I already got 2 phone calls from my bank where they detected a fraudulent transaction. I was very happy with that, because every time it's usually a few $1,000s that's not going to be charged on my account. So and we're talking about sub-seconds. I'm in a shop and I got a phone call that someone is spending my money in a country where I'm not, and using a online system that I'm actually not even online. So they detect those patterns. They know where I am. Sometimes I don't want them to know where I am, but they know where I am, they know my patterns, and they know that there is no match with that transactions. So you need to be able to develop systems and develop these rules and adapt these rules to those new patterns and to make decisions, okay? So we talked about the train this morning, the positive train control system. That's also a very important use cases. So here we have actually devices where urgent data must be acted on immediately. For example, data needs to be sent to the data center about the state of tracks of different segments in your rail systems. Then the rail sensor collect and record the data about the train's route, and the speed, the load characteristic, a number of information that are really relevant to that situation, and all the data passes through the control tier. And I think you've seen that this morning when Brian showed the 3-tier between the actual sensors, the gateways, and to the data center. And that's exactly what's happening there. So the web messaging and business rule software define what to do with the data. So they act on the data real time. So they analyze, they capture the data, they analyze the data, and they can act on that data immediately. So like for example, here you have, as a train nears an intersection, messaging to alter speeds are relayed to the conductor dashboard with highest priority. There is a car on the track, maybe there is, if you're in New Zealand, there may be ships, for example. And information about speed, fuel efficiency, weight, and all that is stored on the data under the data center, and people are being able to analyze it. So if these urgent directions are ignored, then you need, for example, you need some business process flow automation. Let's say the driver is not responsive. What do we do in those cases? You need to not only to have business rules that detect those patterns, but also need to have a business process flow automation behind it. What happens if? Okay? So this is one of the most recent examples, and we have that on our website, actually, at redhat.com with the full interviews. And so that's from these use cases that we derive those frameworks, okay? So that's the high-level solution architecture. So we have a layer of an interface layer that consume those events, whether they come from my Fitbit, from your mobile, from the sensors, from the IoT, from the social media. And here we're talking about data collection and ingestion. We also talk about mobility before. Not only you have the ability to send data, the sensors, like on the train, but also it's bi-directional. We can send data back. The sensor, there's intelligence in those gateways and those sensors where we can actually, for example, trigger an event or change it, like send a signal to actuators to either open a valve or do something else or raise an alarm. So this is both directions. So we have the data analysis part, so where you have the data input first to process that data, whether it's structured or unstructured. And you have a data persistence layer. So typically for NoSQL in big data, we see a lot of Hadoop, which is the dominant player in that space. And we also have the traditional master's data on your data warehouses or your big environments. And so what's very important now is how do you make sense, how do you visualize, how do you integrate and combine the view of both data at rest and data in motion. And that's that data integration and virtualization layer that is in charge of that. So once you've done that, you can present that in the form of dashboard to business decision makers, okay? Whether they act on real time or whether they want to act on events that happen in real time or escalations or data that has been at rest and predict or work on forecasting certain usage. Of course, we have management and development requirements. So you need the tools and you need the capabilities to change those rules and help them to adapt to new patterns. So I'm not going to spend too much time on real-time map reduce, but here is just to show you one of the first feature which revolves mostly around real-time processing of information. So that layer is in charge of receiving the data from your IoT devices, from any streams. Then we don't store the data on disk. We actually use JBoss Data Grid to create an in-memory distributed cache. Okay, so that data you can actually run time-reduced workload on that data. There is no way you can do real-time data analysis if you run map-reduced workload on Hadoop. You need to do that in memory. Okay, so for the short cycle execution we need, this is the decision we make. Once you've actually identified patterns in those, then you can apply business rules. Okay, so that's the first feature, real-time map reduce. The second one is real-time decision. So once you've analyzed that data, you need to have the ability to modify decision rules in real time and accumulate also that knowledge as the rules evolve. I talk about fraud, credit card transaction frauds. Also, they need to learn. They need to be also updated. You don't want to redeploy your environment. You need to act directly. So with JBoss BIMS, that's what we can do. You just redeploy your rules. You don't redeploy your entire applications. Okay, so, and real-time business insight is the third features which builds virtual data view using JBoss data virtualization. So JBoss data virtualization has the ability to aggregate all the different data sources in one unique views for business decision makers. So this can view information via dashboard, or also they can expose that to, if you have existing business intelligence tools, with JBoss data virtualization, you can expose that as REST or web services or different endpoints, okay? And of course, developers and administrators need to have the ability to build virtual tables. So we have all the toolings that people know, and to build these virtual tables, these unifications of views and these dashboards. So here's an example where the role of data virtualization plays is actually you have your in-memory data grid here, so your real-time events are coming here and they've been analyzed. And also you have, so it's a combination of the two that matters here. And that's where we present that as a single unified view. Okay, so now let's go back to the architecture. So how does this JBoss product I mentioned fit into that architecture? So the first part is JBoss Fuse. So Fuse and AMQ are here. So typically AMQ will be here to process messages from the IoT world using MQTT protocol, for example. So This is typically the scope of Red Hat JBoss AMQ. Red Hat JBoss Fuse has different adapters, to connect to different data sources, to consume those informations, those flows. On the data input side, so I mentioned in-memory data grid, so we use JBoss data grid for that. So we're not dehydrating that on Hadoop big data. We're actually keeping it in memory. That's where you run your MapReduce workload, okay? So that's very important. Following that, we have Red Hat JBoss BRMS. This is where you have your business rules, where you can actually, once you have gone through MapReduce, you can apply your business rules and execute those rules against those. And finally, JBoss data visualization to assemble those two different sources, whether they come from in-memory or from the master data on disk. I mentioned about escalation. So BPM acts actually as a business process management. So what happens if the driver is sleeping? What happens if, for example, there is no routing for your, for that organ? Is not 100 kilometers before it reach a place where it can replace that air conditioning unit. Maybe the organ will not be valid anymore. So we need to take actions. So this is what JBoss BPM suite plays a big role in. Okay, so of course you can add mobility because you have an engagement platform. Typically people use the existing apps, but now with Red Hat mobile platform, it's very easy actually to integrate with any of those components and push notification to your devices. Okay, so we have the full loop here. Okay, so how can Red Hat help you if you want to go the real-time big data frameworks way? So we have a methodology that revolves around 3 principles. The first one is to discover. So we go with the customer and discover the environment. That's an opportunity for feedback to know exactly what they're running, which kind of data they're processing, which kind of analytics they need to run on, and what value we could, how can we make sense of that data to create business value. So that's the first discovery time, and usually it's a short time frame. Then after there's a design phase, and followed by, of course, the deploy. So the Red Hat Consulting Services segment those in different engagements of 1 to 2 days, for example, for discovery. When I was a customer, actually, I was migrating from proprietary software to open source, and this is exactly the same engagement framework we had. Discovery, then assessment, 2 or 3 days to actually assess, to have a detailed assessment and also a report on the recommendation to cover target state solution design and scoping for your initial implementation. So this can happen within a week or 2. Then there's a smart start, which typically takes a bit longer in your environment. So deploying the product, starting to focus the introduction of big data analysis for your team, because there's also a change there's a training need to be done also for your ops team, for your developers. So typically that takes 3 to 6 months. Okay, and the enterprise rollout is usually, I think, from the example I show you, we're talking about 9 months. Yeah. Okay. Okay, so I'm just in time by 30 seconds. So thank you. Kamsahamnida. I hope you enjoyed the session.